Alright guys, this is Mr. E here for day 2 of this week. We're going to be doing section 10.3, how do I find the circumference of part of a circle. Alright, so before we get started, again, if at any point you need to pause this video, make sure you do so. And also make sure you're asking questions as we go along. I know it's kind of difficult to do that, but you can make sure you contact us if you have any questions. Alright, let's get to it. How do you find the circumference of a part of a circle? Alright, so let's understand what it means to be a part of a circle. Alright, so let's take a look at the circle here that we have. Alright, part of a circle, as you guys know, is an arc. Alright, so essentially the question is, what is the arc length? Alright, well, that's what we're trying to find. Arc length. When we are asked, how do I find the circumference of a part of a circle? That's what we're actually looking for. What is the arc length? All right, so think about it like this. If you were to get a string, and if you were to get the string and let's just say wrap it around this arc, and then take that same string and then stretch it out, what is that length going to be? All right, that's what the question is. What is that length going to be if you were to take a string of that arc and then straighten it out? What would that length be? All right, so this is what your part of a circle is considered. All right, so this is a part of a circle. Part of the circumference of a circle. All right, so how do you find that? Let's take a look at the formula that we need for that. All right, so if you want to find the arc length, technically that's considered a fraction of the circle times the circumference. All right, so the fraction of the circle is going to be your arc over 360, because that is a fraction of a circle that you're trying to find. All right, multiplied times the actual circumference of the circle. All right, so that is a formula that we use to find the arc length. All right, so let's give it a go. Let's test run this to see how this works. All right, so for example 1, it says we got to find the arc length of the sector below. All right, so I'm just going to take my formula. I'm just going to write it again just so that I get used to seeing this. All right, so we want to find the arc length of this arc right there. We know that the area is something else, and that's going to be tomorrow's video, but for today we just want to focus on arc length. So again, the fraction of a part of a circle. Well, we know that the angle here is 60, so that means that this arc measurement is 60 degrees, so that's going to help us with filling this formula out. So it's going to be 60 over 360 times the circumference, which is 2 pi r. Now in this formula, we need to fill in the radius, which is given to us, which is 8. And all we do from here is solve. So arc is equal to, all right, well, I'm just going to simplify this before I put this in a calculator. Zeros cancel out, so 6 over 36, which is 1 over 6, times 2 times 8. Well, that is 16 pi. All right, so the arc of this is going to be 1/6 times 16 pi. Well, if you don't know what that is off the top of your head, just get your calculator and let's just figure that out. All right, so you can do this several ways. You can take 16 pi and divide it by 6. So the arc length of that piece of circumference is about 8.38. Let's just round it 2 decimal points. So that is the arc length, 8.38 units. All right. So a more accurate answer would be actually leaving it as a fraction. So arc is equal to 16 pi divided by 6, which can be reduced to 8 pi over 3. That would be a more accurate answer, but this works as well. All right, so let's move on to the next one. Just try it again, just so that we understand and get a different and new example. All right, so for example 2, we're asked to find the arc length, all right, of this circle right here. So again, let's just use our formula. See if I can get it pasted actually. I feel like I'll just copy it again if that's not working. So get this, copy, paste it on down here. All right, here it is, formula. So again, we need to find the part of the circle, the arc length. So the fraction of the circle is, in this case, going to be 80 over 360, because that is what measure of the arc is, 80. And in this scenario, we know that the radius is 6. That is what we're told right there. That is 6. So once again, you could easily type this into your calculator, figure it out. Otherwise, you can reduce and try to solve it that way. Zeros go away. 8 over 36. So 8 over 36 times 2 times 6, that's 12 pi. All right. Well, again, if you don't want to deal with fractions, you can easily type this into your calculator. And I'll show you how to do that now so you can get your answer right away. So arc is going to be about, and again, let's get our calculator out. So in this case, we have 8 over 36 times 12 pi. And again, if you don't want to deal with the fractions, you can have your calculator do it for you. It just matters how you put it in. You would have to say parentheses 8 divided by 36 times 12 pi. You hit enter, and that is about 8.37 again, or 38 if you round to the nearest hundredth units. All right. So again, if you want to do 8 divided by 36, you get that decimal. And if you want to switch that to a fraction, you can do math and then hit fraction option. So math, fraction is the first option, and it'll switch it to a fraction for you. So if you're uncomfortable with fractions, you can have the calculator do it for you. So that would be what 8 divided by 36 is. But again, this is an approximation, so this works. All right. If Desmos tells you to use 3.14, then you use 3.14 instead of the pi button. All right. So moving on to the last one. So this is a little different because we're asked to find out what the measure of arc AB is in degrees versus what the length is. All right, so it says if the circumference of the circle is 80 pi, so we're given the circumference. And again, let me just get my formula again because, again, that's what we're using for this. All right, so we know the circumference, that is 80 pi. And the arc length is 19 pi, so we actually know the arc length. We know what that stretched out portion is. We need to find the measure of arc AB. So what that means is we want to find what that part is in degrees. All right, so we're essentially working backwards here. So since we know pieces of information, we can actually replace those pieces in our formula. So the piece that we can replace based off of the circumference being 80 pi is the red section that I highlighted before. So this section technically is considered 80 pi because that's part of the information that we're given. And then the other piece that we can replace is the arc section, which is 19 pi because that's also given to us. All right, so that is what we have here. So now that we have our formula, our goal is to find what x is. We need to find what the portion of the circle is in degrees. All right, so in positive algebra, we've got to get x by itself. First thing we want to do is just get rid of the things that makes us uncomfortable, and hopefully that thing that makes us uncomfortable is a pi. So if both sides of the equal sign have a pi, then we can get rid of it through division. So divide both sides by pi. Pi's go away. And now you're left with kind of a two-step equation. So we're left with 19 equals x over 360 times 80. All right, so on the right side we have 8x over 360 times 80, which reduces, or it can be simplified down to just 80x over 360. And now here we just have a two-step equation. If we want to get x by itself, we would multiply both sides by 360. 360's go away. You have 80x equals 19 times 360 is 6,840. Divide both sides by 80. X equals 85.5 degrees. So that is what that length is in degrees. Gotta make sure you ask any questions, rewind, or watch the video again if you missed anything.